Hello and welcome back to our series on systems of equations. This is going to be our word problem number 2 in this series. So let's jump right in. Mr. Veach has a classroom of 180 students. They just took exam 1 and exam 1 didn't go so well, so he let the students choose between 3 extra credit assignments. The first is worth 5 points, the second is worth 10 points, and the third is worth 15 points. And obviously if this was true, this would have been a lot easier than the 15-point assignment. So the number of 5-point assignments handed in equals the sum of the 10 and 15-point assignments. The number of 5-point assignments is 3 times the number of 15-point assignments. How many extra credit assignments of each was handed in? Assume that all 180 completed the extra credit assignment. Alright, so first we have to label the 3 assignments. So we'll let X equal the number of 5-point assignments. Y will equal the number of 10-point assignments. And Z will equal the number of 15-point assignments. Alright, now let's go through the information that we have to see if we should have, now since we have 3 variables, we should be able to get 3 equations. So let's see, first line, we have a classroom of 180 students, and each student turns in an assignment. So when I say number of 5-point assignments, each assignment is turned in by a student. So the first thing I know is I know that X plus Y plus Z has to equal 180. So because each one represents a student, so if you were to add up all of the assignments, we should get 180. What else do we know? Okay, so we have the number of 5-point assignments handed in equals the sum of the 10 and 15-point assignments. So what that says is that the number of 5-point assignments equals the sum that's of the 10-point assignments plus the 15-point assignments. And what else do we know? The number of 5-point assignments 3 times the number of 15. So what that says is whatever the number of 15-point assignments, you have 3 times more for the 5-point assignments. So now this is usually the tricky one, because is it going to be X equals 3 times Z, or is it going to be 3X equals Z? Sometimes people struggle with this one. So all you got to do is give yourself an example. If Z equals 10, what is X? That'd be 30. And does that make sense? Is there, when you say there's 5 times more 5-point assignments, or I'm sorry, there are 3 times more 5-point assignments, and that's true. So we actually want this one. Alright, so let me erase this. Let me rewrite it. So we have X equals 3Z. So now I have my 3 equations. 3 variables. I'm going to do a augmented matrix, and we're going to row reduce this. So first thing is let's write this so that all the variables are on the same side. So we'll have X plus Y plus Z equals 180. Then the second line we'll have X minus Y minus Z equals 0. So notice when you bring the X and Y, or I'm sorry, the Z and Y over, there's nothing left on the right hand side, so that's going to be 0. And then this, we're going to get X minus 3Z equals 0. Because notice that when you bring this over, there will be nothing left on the right hand side. Also, there's no Y, so I just left a space here. You could put 0Y if you would like. Okay. Alright, so there's our system, so let's write it into our matrix. Remember, the matrix consists of only the coefficients of all these variables. So our first line will be 1, 1, 1, and 180. The second line will be 1, negative 1, negative 1, 0. And the third line will be 1, 0, negative 3, and 0. Okay, so this is our system in the matrix. So now let's row reduce this. Okay, so when starting row reducing, you want to change this into a 1 and then these into zeros. Well, this is already a 1, so we're off to a good start, and we want to change these to zeros. So our first two row operations will be row 2 minus row 1. Because what happens when you take 1 minus 1? Well, you're going to get 0, and that's exactly what I want. We're going to store that back into row 2. Same goes for row 3. So row 3 minus row 1. Remember that these always have to be, this is your pivot row. So these always have to be the same. And that we're going to store back into row 3. Alright, so let's get started. We're not changing row 1, so I'll leave that alone. Alright, so let's go down and do our work. Alright, so let's do the first one. So we got row 2 minus row 1. We're going to store that back into row 2. Alright, so row 2, all the numbers from row 2. So we got 1 minus 1, well, just, yeah, row 1 is 1, and that's 0. Then we're going to get negative 1 minus 1, that's negative 2. Next we'll have negative 1 minus this 1. That's going to get us negative 2 again. And then we're going to have 0 minus 180, which is negative 180. We'll put that in there. Alright, so we're done with that row. Let's move on to row 3. And that's going to be row 3 minus row 1. Okay, so we get 1 minus row 1, so that's that one. Alright, this gets stored into row 3. That's 0, which again was supposed to happen because once this is a 1, these are supposed to be zeros. Then we're going to get 0 minus 1, and that's negative 1. And then we're going to get negative 3 minus negative 1. Oh, wait a minute. I think I said that wrong. The negative 3 minus this one. So negative 3, so not that one. So negative 3 minus this one, that gives me negative 4. And then we're going to have 0 minus 180. So 0 minus 180, and that's negative 180. Now let's move on to our second set of operations. So we want to turn this into a 1. We can either just turn this into a 1 by dividing by negative 2, or we can swap row 2 and 3 and bring this 1 up and then multiply by negative 1. But I think it's okay to just divide, or we can multiply the second row by negative 1/2 because we're not going to get fractions, so we'll be good. So we don't change the first row. Alright, so then 0 times negative 1/2, that's 0. Negative 2 times negative 1/2 is 1. Negative 2 times negative 1/2, that's 1. And then negative 180 times negative 1/2 is 90. And then we don't do anything to row 3. Okay, and there we go. So now, now that this is a 1, we're going to turn these into zeros. So let's go ahead and do that. Okay, so we have row 1. So it's going to be row 1. Now if this is a 1, then I just need to I need to make this a negative 1. So we're just going to subtract row 2, store that back into row 1, and then we have row 3. Now since this is a negative 1, then this just needs to be a positive 1, which it already is. So it's just going to be row 3 plus row 2. And store that back into row 3, and we're ready to go. So let's do the work on our first row. So we got row 1 minus row 2, store into row 1. So we're going to get 1 minus 0, that's 1. Then we're going to get 1 minus 1. So 1 minus 1. And that's 0. And then we'll get another 1 minus 1 from these. That's 0. And then we'll get 180 minus 90. And that is 90. So we'll put 90 up here. Alright, so we're done with the first row. Let's move on to the second row, or third row, sorry. So that would be row 3 plus row 2. Store that back into row 3. So we'll get 0 plus 0, which is 0. Then we'll get negative 1 plus 1. So negative 1 plus 1, that's 0. Again, that was supposed to happen. And then we'll get negative 4 plus 1. That's negative 3. And then we'll get negative 180 plus 90, which is negative 90. And there we go. Let's go ahead and put back in row 2 since we didn't have to change anything. All right. All right, we're getting really close to being done. So now let's use this matrix. Notice that I just need to change that into a 1. So I'm going to multiply the third row by negative 1/3. So let's go ahead and do that. So negative 1/3 times row 3. Store that back into row 3. So we're not changing anything to the first two rows. And so now negative 3 times negative 1/3 is 1. And negative 1/3 times negative 90 is 30. Okay, so here's our new matrix. So let's do some row operations with this one. This will also be our last row operation. So we have our diagonal of 1s now. So I just need to make these into zeros. This one is already a 0, so I just have to deal with this one. So row 2, it's the only one we have to change. So we get row 2. Now that's a 1, so this would have to be a negative 1. So we're going to subtract 1 times row 3. Store that back into row 2. And that's all we have to do, so let's do the work now. So we get row 2 minus 1 times row 3. Store that back into row 2. All right, notice that these don't change. Once you're done with the column, you're done, so they don't change. So this will be 0, 1. All right, so now let's deal with these. So we have 1 minus, so that 1 minus this 1, and that's 0. And then we're going to have 90 minus 30, and that will be 60. And I'm not doing anything to row 1, so that's going to stay 1, 0, 0, 90. And I'm not doing anything to my last row. And I am completely row reduced now. I have my diagonal of 1s, zeros everywhere else. So let's read off our answer. We have x equals 90, y equals 60, and z equals 30. All right, now x represented the number of 5-point assignments. So let's go write that up by the word problem. Okay, so let's do a quick check. So x plus y plus z, does that equal 180? So if you were to add these together, do we get 180? And we do. Does x equal the sum of y and z? Well, y and z are 60 and 30. And does that equal 90? Sure does. And then last one, does x equal 3 times z? Well, z is 30, and 3 times 30 is 90, so that worked out. So there's our final answer, 90 5-point assignments, so 90 students for the 5 points, 60 for the 10-point assignments, and then 30 did the 15-point assignments.